All right, let's talk about one of the biggest questions in finance. How do you figure out what money in the future is actually worth today? So let's just jump right in with a thought experiment. Imagine I promise to give you $1 million. Sounds great, right? But the catch is, you don't get it for 5 years. So how much is that promise really worth, right here, right now? I'll give you a hint. It's not $1 million. And figuring out why and what the real number is, well, that's exactly what we're about to break down. The whole reason for this is a huge idea in finance called the time value of money. And it's simple, really. A dollar in your hand today is worth more than a dollar you get tomorrow. Why? Because you could take that dollar today and invest it, right? You could earn interest. And then there's stuff like inflation, which erodes its value, and just the risk that you might not get it. All those things chip away at the value of future money. Okay, so how do we actually calculate for all of that? Well, finance pros have a really powerful tool for exactly this problem. It's called the discounted cash flow model, or what everyone just calls DCF. Really, what the DCF model does is answer one simple but crucial question. It looks at an investment, could be a whole company, a new project, anything, and it asks, based on all the money this thing is going to make down the road, what's it worth in today's dollars? It boils everything down to a single number. The entire process really comes down to 3 big steps. First, you've got to make an educated guess, a forecast of how much cash the investment is going to produce in the future. Then, step 2, you have to discount that future money to figure out what it's worth today. And finally, you just add it all up. That's it. And this is the little engine that makes it all work. Now, don't let the formula scare you. We're not going to do a big math lesson. All you need to know is CF is your cash flow, T is time, and R is the really important one, the discount rate. You can think of R as the rate of return you could get elsewhere or the risk involved. It's what turns future money into present value. Okay, enough theory. The absolute best way to get this is to just see it in action. So let's get our hands dirty and run the numbers on a simple project. So here's the setup. We're looking at a project, and we think it's going to generate a nice, steady $1 million in cash every single year for the next 5 years. And we're going to say our discount rate, that R from the formula, is 5%. These are our basic assumptions. Let's see what happens. And here we go. This is the magic. Just look at that present value column. That $1 million we get in year 1, it's worth about $952,000 today. No big surprise. But look at year 5. That same $1 million 5 years from now is only worth about $783,000 today. See how the value shrinks? The further out the money is, the less it's worth to us right now. So when we add up the present value for all 5 of those years, we don't get $5 million, not even close. We get a little over $4.3 million. And that number, that represents the total value of that entire 5-year cash stream, all pulled back into today's money. But hold on a second. Most businesses, if they're any good, don't just stop after 5 years, right? They keep going. So what about all the value they create after our forecast? That's actually the next and maybe the most important piece of this whole puzzle. This really is the $1 million question, isn't it? How in the world do you calculate the value of a business from year 6 to year 20 to, well, forever? You can't possibly forecast that far out. The way we handle this is with something called terminal value. It sounds complicated, but it's basically a single number that's meant to represent the value of all the cash flows from the end of our forecast period, on and on into the future, assuming the company just keeps growing at some slow, steady rate forever. So using a pretty standard formula for this, and assuming our little project grows by a stable 2% a year forever, the terminal value comes out to a whopping $34 million. Now think about that. That one number is supposed to represent all the value from year 6 into perpetuity. It's huge. But remember the rule. That $34 million is a future value. We're calculating it at the end of year 5. So we still have to do our thing and discount that number back to what it's worth today. And when we do that, its present value is about $26.6 million. And now we put it all together. You take the value of the first 5 years, our $4.3 million, and you add the present value of all the years after that, the $26.6 million, and that gives us our grand total, our final answer for what this whole project is worth, just under $31 million. That's the number we've been working towards. So what's the point of all this? Well, now you can make a decision. You take that value, our $30.9 million, and you compare it to the cost. Let's say this whole project costs $20 million to get off the ground. Well, the verdict is pretty clear. Our analysis says it's worth almost $31 million, but it only costs $20 million. That looks like a pretty good deal. The project gets a green light, it's financially viable. Now, before we run off and start using this for everything, we have to be honest. The DCF model is powerful, but it is not a crystal ball. It's just a tool. And like any tool, it has some major strengths, but also some really, really big weaknesses. Sure, it's comprehensive, it's flexible, and everybody in finance uses it. But, and this is a big but, it is incredibly sensitive to your assumptions. Change one of your guesses by just a little bit, and your final answer can change a lot. And as we saw, that terminal value, which is the biggest guess of all, often makes up most of the final number. This image right here shows you exactly what I mean. It's a heat map of our project's value. Just look how fast the color goes from purple, which is low value, to bright yellow, super high value. And all that's changing are tiny little tweaks to the discount rate on the bottom and the long-term growth rate on the side. The answer is all over the place, based on what are, let's face it, just educated guesses. And that brings us to the most important thing to remember about all of this. The DCF model is less of a precise calculator, and it's much more of a powerful framework for thinking. It forces you to ask the right questions. What drives this business? What are the real risks? How fast can it realistically grow? Which leaves us with one final big question to chew on. If the entire model, this whole sophisticated calculation, is built on a foundation of guesses about a future that nobody can predict, then how much can we really trust that final number? What does value even mean? That's something every investor has to decide for themselves.